You can go.
So yeah, I have a quick review of like the motivation and the data I've been using, and then I'll go into my analysis. So just where I'm getting my data from, I'm looking at the National Health Interview Survey from 2018, specifically the sample adults data set. But that has 742 variables, so I'm limiting my scope to the variables relating to gender, race, age, functional limitations. So if someone has a functional limitation, employment status, and the number of days they have lost because of health concerns in a year, work days they've lost. That's number of sick days. So I have some research questions. So are these demographic variables I'm considering? So the variables for functional limitation, employment status, and lost work days, those to me looked least top-coded or altered in any way. I'm sure they are altered, but unlike some of the other variables that have like race has some of the answers removed because it could limit or could increase risk for identification, and age was top coded. These ones looked more like they would originally, so that's kind of why I chose them partially. So I chose those. So what was the relationship between predictors and the synthesized variables? Can we best preserve this relationship? How do we preserve the usefulness of the microdata to make sure it's has high utility for future analysts, and how can we also symbiotic or at the same time minimize risk? This also isn't super, you guys are aware of this, but under Title 13, it is legal for the U.S. Census Bureau, which conducts the National Health Interview Survey, to disclose or publish any census or survey information that identifies an individual or business. And then I described the process of generating synthetic microdata. So we fit our data by way of Monte Carlo approximation or MCMC, and then we use the posterior to calculate new values for columns of interest of the synthesized variable, or the variables we choose to synthesize. So this is just describing first the predictor variables. So as you can see, 5 race not realizable. That is another kind of similar maybe to top coding, or a similar method to top coding. And then you can see that age is top coded here. And then these are the variables to be synthesized. So you can see that functional limitation is binary, work status, so doing LWA, is categorical, 5-level categorical, and then workday is lost work days. It is continuous, but it only takes integer values here, so I consider it as count. So counting the number of days you missed or were able to make. So my model, I use a logistic model for functional limitation, which I'm pretty sure I've described before, but I use sex and race variables as predictors here, and then kind of uninformed or priors for mu and sigma for all beta I. It's really hard to write out what formally the multinomial logistic model, and I haven't quite figured out how to make it like understandable to read, so I just copied over my model string, but I'm gonna improve this before I turn in my write-up. But as you can kind of see what we're doing, so there's a categorical P is a matrix for each P is a matrix of so P for each I is a vector of probabilities for this categorical variable, or for to determine like which category it comes from, and then we use kind of the process of so each the logistic model, how the logistic model works to my understanding is it's a logistic model between the one you're at now and everything happened before. So is it anything in the stuff that happened before, or is it coming from this certain category now? Is kind of how it works. And then I give pretty broad parameters there too for each beta I. And then for my final variable, I use a Poisson regression, which means I'm giving it predictor variables. This is what I had the most trouble with. So my predictor variables my count data is super over dispersed. So in Poisson, it assumes that variance over mean, so that ratio is equal to 1, whereas for me it was equal to 88, which means it's incredibly over dispersed. So to try to adjust for that, I add a error term, eta here, to add back some of the dispersion, basically. But that takes a really long time to converge, and I haven't been able to give it. From my understanding, it's not converged, so I've thinned it to 200, and my effective sample size for it is about 200 as well. So it doesn't look like, of the 5,000 sample I'm asking my MCMC to take, it's still like just not, it's not converged. And you'll see the effect of that in my results. So this is my system of synthesis. So first I generate functional limitation, and then I use the synthetic functional limitation and under predictor variables to generate work status, and then I use those and age those synthesized variables and age to generate lost work days. So you can see in my results from this histogram that the functional limitation synthesis looks pretty good on first perusal. Same with the work status. So the logistic models seem to be working pretty well. But for the Poisson model, it's really, we don't see a linear trend, and you can see that maybe my range is 0 to 85 here, and the range for the original data is 0 to 350 or so. So it's definitely not capturing a lot of that in the model. But if we look at some of the utility measures, these are not, anyway, if we look at some of the utility measures, so propensity score and cluster analysis, they look pretty good. Even particularly here, look, oh, that must be wrong. Look surprisingly good. And then I must have just copied the wrong thing there, but that's about what it was, which didn't really make sense to me here. So maybe I ran the wrong thing when I was looking at it. And then for identification risk, Um, we It looks pretty good to me. This is kind of the same as what it was before. So I ran this originally when I was just using a like a simple Dirichlet multinomial model for my second synthesis. So that had no predictors. And these were pretty similar. So actually, no, this was about 19. So yeah, it changed significantly. And then this went from 99 to 93. So you can see the effect of having those parameters on the risk. And then kind of for a discussion, I would like to in the future find a better model for the Poisson regression, or for the third regression, or the third model I did, third synthesis I did for the workday model, because it really doesn't seem to capture the range. And then this is a typo, but I think maybe I should remove some of my predictors for the doing LWA variable synthesis because it does change significantly the risk. In the future, I would maybe do that. Yeah.
Thank you, Sarah.